Yes, please go ahead.
Okay,
Leonardo,
good.
can you stream it for the YouTube?
Yeah, I will start it.
Great.
Thanks.
Thank you, Mojtaba.
No worries. Good afternoon, everyone. My name is Mojtaba. I'm a senior data scientist at Knab currently. And thanks to Marzi, you invited me for this presentation to explain a little bit about NLP and the large language models, and but more of on how to use it in a practice or in a basically business. I will give a little bit of a background about myself. I received my PhD in computational physics. I started my career as a data scientist around 2017 or so. I moved to ING. That was a place that I met Marzi. I was quite lucky that I worked in different domains within ING, where I developed some NLP use cases. That's why I'm here to explain some of those use cases to you. Currently working at Knab, mainly focusing on generative AI solutions, and more specifically utilizing these large language models for customer-facing chatbot and also internal chatbot to basically make it available to colleagues to be able to retrieve the answer they want from company documents, policy, standards, and etc. Before going into a lot of the details, I would like to start from how everything evolved. I would call it the evolution of a large language models. You can see in this picture before 2013, or I don't know, around that time, there was not much hearing about, not much improvement or big improvement when it comes to unstructured data, and was mainly on tabular data. And back then, people using more of some statistical model trying to, predict or, what is the likelihood of a word given all the previous words. But around 2012 or 13, it tried to kind of picked up the pace, mainly because of some development in deep learning models. More specifically, in 2013, they managed to use some sort of a shallow neural network to bring more of a context to the words. Then it evolved in 2018 or so. That Google introduced transformers. It was a big change in NLP, and it moved to the different level that we could understand that context of the words within a sentence, and introduce a new architecture that all different basically parties try to use those architecture to build their own language models. And in 2020, you're all familiar that GPT-3 came in and it changed the world basically. And that's where we are now. And it's booming at the moment. So as I said, I started my career around 2017 or so. So if I put it in this timeline, it was a time that there was not BERT or those medium language models, I would call it, in place. So what we had at hand was those statistical methods or approaches and word to vec and some of those deep learning approaches to tackle that, okay, how we can break down these sentences, understand more of a semantic and syntactic of the words, right? Okay. Around that time, I got involved in a project, and that project was the users were struggling to collect the document for a certain query, basically. Suppose they wanted to see that, okay, how many documents we have within the company related to certain things. You can imagine money laundering, right? Okay, in a banking environment, or a data leakage, right? You want to see that, okay, how many issues basically registered related to money laundering or a data leakage. So they could. What they did back then was using Excel. As you can imagine, that is a horrible application to work. Well, for this particular case, obviously, I mean, it has a lot of other usage. But when it comes to the text, in order to collect a lot of, issues and document, it will be difficult to work because you need to do some exact matching. And when it comes to exact matching, then you will face a lot of problems because there might be misspelling. There might be diverse words in the different forms. So obviously, Excel was not the best, tool for them for this particular case. So our task was that to tackle this problem. So we tried to tackle it with the search engine. And in order to fix all the issues that they had faced, so we had to think of it that how we can leverage all those NLP basically technique or methods, right? I mean, all those statistical approaches, deep learning approaches to tokenize our text, bringing those sentences in basically a unit, I think called tokens. Then removing stop words from the sentence, like, some articles, the word like the, and this sort of thing doesn't have much of a value when it comes to the search because you don't search for those particular words. So removing those items or finding n-grams. That was a part of a processing text. N-grams mean that I told you, I give an example, like searching for the money laundry. Money laundry is called the bigram tokens. It's two words coming together gives a one specific meanings. So essentially, we try to utilize all those packages or approaches we have at hand to parse the text first, then be able to search through it. So tokenization, removing the stop words and n-grams is a part of those processing. I want to show it to you that how we did it before in a demo form. Then the second part was the search, right? In the search, it happens often that you might be so fast or quick and you might do some misspelling. So then we had to basically fix those misspelling using the fuzzy matching. So fuzzy matching is some technique trying to understand that how two words can be close together. It can give some sort of a score that, okay, the word A with word B, how close they are based on certain criteria. It can be that how many characters I need to change to become to the second word. And some other criteria is called the fuzzy matching. One more thing we did, which was taken very well by our user, was semantic expansion. So as I said, our user wanted to find certain documents. So essentially, sometimes you look for documents related to, suppose, money laundering, right? But there might be some documents related to money laundering which there is not the word of a money laundry per se there, but there might be some other words related to money laundering in that documents. So that documents per se is related to money laundering, but doesn't have money laundering word there by itself. So we try to see that how we can expand that word or query that the user is looking for. Because sometimes they that, okay, maybe I'm looking for a data leakage. Then you could say that there might be some other word. Then you started thinking about other words might be related to the data leakage based on the documents we have. So that we did the semantic expansion, as I said, how we did it. So we try to utilize it word to vec. You might be familiar with the word to vec to some extent. I don't know, but just to give you a gist of it, is a shallow neural network. On the left side, it has a two flavor, is a skipgram or CBOW. In a skipgram is that you give the word and try to understand what would be the other word surrounding this word. And the result of this basically shallow neural network is a vector space. And within this vector space, what we have is that we see that words that semantically related to each other, they've become closer to each other. So that's how we try to tackle semantic expansion. So if you look for a word like money laundering and data leakage, our word to wake could give you some options that, okay, you're looking for a particular query, but there might be some other queries that are related to money laundering. So I'm going to show it to you how you can do it. By the way, if you have any question, please ask, because it's like, it will be much more interesting if we keep this presentation more interactive. Do you see my screen, Steve?
Yes.
Yeah, so what I did is that I just took out Amazon Fine Food Review from the Kaggle. So I'm using some packages. Back then, these packages were our kind of only used packages. It's called the Spacey and Gensim. They contain many different language models that they can do different type of a task for you. So back then we had these two packages available for us to use. So this is a Kaggle data set. So I just read that Kaggle data set is quite large. So what we can see that what we have in this, yeah, you can see that it's product, summary, and text. What I will be interested is that I will pick out the text. I'm trying to build this word to wake and to see that how I can play around to see that what sort of words are semantically close to each other. So from that Spacey package, I told you that you need to load what sort of a model you're looking for. I basically load an English model. What I would do next is that I will tokenize it and lowercase it, because yeah, if you want to search it, then you don't have a problem with lowercase or capital case. So during the tokenization, what I would do is that I go through the text. I will break down that chunk text into sentences, basically trying to understand that how many sentences exist in that text. I will keep only tokens that is not a stop word and is not a punctual, like a point, I don't know, exclamation mark and stuff. So I remove those stuff. I only keep the other basically words or verbs. So yeah, I will run it and apply it to that text column. And I will put it in a new column. It's called the tokenized. And in order to make it a word to wake, it's very simple. I just need to create a list of sentences, and you can define that what would be the size of your embeddings, because this embedding size, we don't know exactly what it is, but it can represent different aspects of different aspects or direction in that vector space. It can be a gender, it can be, I don't know, royalty, it can be food and stuff. We don't know. That's something that network itself recognizes it. So yeah, and I can decide to go for a skip gram, and there are some other parameters that you can tune. So I will build that word to wake model. It takes a couple of minutes. It's not taking so much time. So then I will start to play around with that. So I load it. Maybe I don't need to load it anymore. Let's try. So for instance, it's a Amazon Fine Food Review, right? I will start with the pizza. You see that I already put it. So what's constructed from this text word to wake is I try to understand what other words are semantically related to. Obviously, pizza, there is a pizza. I mean, we could also work out to bring down plural form into single form as well. Crust and meatloaf and pastorelli. So if I search for delicious, so yeah, obviously the word like a tasty, yummy, delicious, wonderful, flavorful, these words becomes much closer in that vector space. And if I try, let's try disgusting. We're talking about food. So obviously, awful, gross, nasty, and this sort of word will pop up. That's how I try to build this query expansion in our specific data set. I will go back to the presentation. So that was a demo. I have one question for you. If someone knows, what's the issue and problem with Word2Vec? Does anyone know? No? Okay. I will go ahead with it. So the issue with Word2Vec is that it's static, meaning that for each word, we have a one vector representation. So then we have a problem. The problem is that the word like a mouse, it can be keyboard and mouse, and it can be a rodent, basically. For a word like a mouse, we have a one vector representation. We don't make any basically differentiation what mouse means in this context. So that's how basically it made a lot of changes. It was a kind of explosion in the market when transformers came in 2018. And I believe you know the transformer architecture. It contains of a two component. On the left side, you see encoder. On the right side is a decoder. Encoder part basically encode the text, basically put it in creating those embedding or contextualized embedding. And the decoder part, basically, it can do prediction for you. So the essential part, the component of the transformer is that multi-head attention or multi-head attention, I would say. And what it does is that, let me give you a little bit of a background. So the issue was that how we can understand that words within the sentence are related to other words within the sentence. It was always a challenge. From Word2Vec, then it started to move around LSTM and some other deep learning approaches, and they were all struggling to see that a word in the middle of a sentence, how it's related to the word at the beginning of a sentence or end of a sentences. So this problem was solved with the transformers. So, and especially or more specifically with that multi-head attention. What it does is that it tries to understand that each word within a sentence, how is related with other words in the same sentences. And it was particularly successful and very powerful and solved that problem that we were facing for a long time, that how a certain word within a sentence related to other words in the same sentence. That brought a contextualized embedding. In this particular case, a word like a mouse, it depends in what sentence it is, it might have a different basically vector representation. So that's something that we didn't have it in Word2Vec. So 2018, I moved on to another project. It was a time that Transformer came in, and more specifically, BERT from Google. BERT, it's only an encoder. If you look at it on the left side of this transformer, meaning that it's going to generate for you a contextualized embedding. So it gives a lot of opportunity for you, because what you can do is that you can add some layers of dense layer on top and train it based on your data set. So I moved to a new project, and the project was that how we can analyze customer or employee feedback. It's a very common use cases within industry. Any type of industry you go, you might face this sort of use cases. You might have a product, so obviously you receive a lot of feedback from your users. You want to review your product. How's this product doing? What sort of a topic people are talking, referring to this certain product? What is their sentiment around that? It can be employee feedback. You know, HR will do a lot of surveys throughout the year, and they want to know that, okay, our employee, what problem they have on what certain topic, and what is the sentiment around that. It's a very common use cases that you might face in business, and you might do it also in a chatbot back then. So it was before, we are talking about before LLM. So back then there was a question that, okay, in a chatbot, how to detect intent of a customer, because how it was before is like a flow, right? You start in the chatbot your question, we try to detect what is your intent, based on the intent, trying to generate some new questions for you. So it was an intent based. So essentially, we could use BERT utilizing contextualized word embedding, put some layer or dense layer on top of that, and train it for your specific use case. So I had a use case of a topic modeling and sentiment analysis. I trained BERT essentially. It was not a large language model that you need to suffer. It was in a level that you could basically train BERT, and you can benefit a lot from that, because now the texts are much more enriched. So for a model perspective, it was easier to learn from these enriched embeddings. Any question? No? Okay. I will move on in time. So let's look at this picture. You see on the left side, before 2020, it was BERT. So I remember around that time, there was GPT-1 as well. You see that around 2020, you have a GPT-2. Before 2021, we have a GPT-3. You see that then from there, that time started to explode the number of large language models. And if you look at it at the top, it shows all those chatbots basically. And I can see that, I believe this is the time that ChatGPT came in, somewhere at the end of 2022, and it changed the game. So I believe you guys are in a good position, a lucky situation, because ChatGPT not only changed the market of basically large language model, on the other hand, it brought this perspective that AI brings values, because all the business, they had access to that ChatGPT easily, and they could see the value of a ChatGPT from my perspective, and they could see the value of the AI. So it brought to a lot more attention that, okay, we can benefit from AI. And back then we had to really convince business that, okay, we can benefit from AI, but the result was not very tangible for them. But ChatGPT brought this to this attention that, okay, you know, you can interact with it and you can see how powerful it is. So that's how we evolved. We are now entering to the time of large language models. And the question was that how we can use large language models. Now we are in a company and we're going to use it in a business, how we can get a value from large language models. So what we can see in business, I believe you're familiar with RAG. I will give an explanation a little bit. So the issue with large language models is that there is a cutoff training time, meaning that it's not up to date with the latest information. So this is the first thing. The second thing is that if you want to use it for your own company, you might have tons of different documents that those large language models didn't see those documents and haven't seen those documents. Essentially, you want to utilize those information as well. Otherwise, you wouldn't get the response from LLM based on your own document, because it hasn't seen those documents. The third thing is that it helps to bring trust, more of in the sense that if you use LLM as such and ask question specifically related to your company, it might give you some information or answer that is not entirely correct, basically. We call it hallucination. Another thing is the more developer control, more in the sense that you have it under your control. You don't need to train it in LLM. You just need to update the documents regularly. So it's more of on your control. So if you look at it at the naive rack, if I want to explain it, so this time, instead of asking LLM and get it only reply from LLM, we just feed LLM with some information of your company or documents. So how it works is that you have documents at hand. It can be your company documents. You need to put it in a vector database. So how it works is that you need to find a way to chunk your big documents into something smaller and save it in a vector database and index it. So when the question from query come or user ask a question, first thing you would do is that send this query to retrieve the relevant chunks from your vector database. You use the user query and this retrieve the chunks from the vector database and provide it to the LLM and ask LLM that, okay, this is a user query. These are the contexts that basically retrieved from our vector database. Now generate an answer based on that. Essentially, we are feeding a frozen LLM with our data to generate a response for a query, for a given query. That is a commonly used use case within industry because, as I said, cost effective. You don't need to train an LLM. It's up-to-date information, and the response is basically based on some ground truths. And you have a much more control because if your documents within the company gets updated, you will also update those vector database. Okay, this is a naive rack. It's getting much more advanced now, moving to the advanced rack because try to put a lot of more tuning knobs, I would call it, to make basically the response better and more higher quality. So, as I said, when it comes to documents, how you chunk those documents has a different variation to do it. When user ask a question, you can do query rewriting because still how I see that people have a problem with prompting. Query rewriting, query expansion can help that, okay, to get a better retrieval from the vector database and also help the LLMs to generate better reply. They have a post retrieval. You can do re-ranking. You can do summarize all those retrieved documents. You can do a couple of different re-ranking and put them together. There are different flavors that essentially you can use, and people use it nowadays in the industry to get the best result out of it. Any question? Then I will ask you a question. So I want to build a chatbot based on RAG. So again, quick review. I send my query. What happens that I go to my vector database to see that what documents are related to my query. I retrieve them, send it to LLM. LLM generate a response. Okay, perfect. So we found the use case. Yeah, okay, we want to build a chatbot. We have a lot of the data. It can be our website. It can be frequently asked questions, right? And what we want to build something like that, right? We can put all those website or frequently asked questions in our documents. User, you can ask any question. I have a problem with certain things. We go to the documents, find the answer, and send it to basically back to user. If I go with RAG, what would be the problem in chatbot? So suppose you're a user, right? You go to the website, open the chat, right? Starting to chat with our basically RAG chatbot. What would the problem?
The time?
Time, you mean?
The delay in the response.
The way that it responds, you mean?
The delay in the response.
A delay in response. Okay, that's possible. Yeah. But okay, still, I mean, you can. Essentially, latency is not a big problem. So, I mean, you might get a response of, I don't know, 5 seconds or maximum 10 seconds. I think you are still patient enough to get a response in 5 or 10 seconds. Maybe I can give you, okay. You as a human, right? You go to the website, you fire up the chat, and you start with hi, right? You start with hello. So if I start with hi and hello, what would happen in this scenario? It goes to the documents, trying to find what are the similar documents to hello and hi, right? Does my document contain word for hello? So you see that, okay, RAG now is a bit struggling. So because a customer might ask, hello, how are you? I mean, this sort of document doesn't exist there, right? So when we face, and when we move to the basically bringing to the production, we face this sort of scenario a lot. So that's essentially, we move into the direction of agentic AI. So trying to basically understand that for a certain scenario, find certain agent to reply or response to it, right? So I can define it that, okay, if customer asks some greeting, hi, how are you? I don't need to send it to RAG. I send it to some other direction. So I send it to basically reply to the customer when asked for a hi with a, I don't know, nice tone, be friendly, right? I don't need to send it to RAG. So here is basically agentic AI comes in, because it tries to fetch, you do the basically rerouting the different part, you can fetch information from a different part and then ask LLM to reply. I can give another example, right? The question comes that the app is down, right? If it goes to the RAG, I'm not sure that what you can get from the RAG. But what I can do is that I can do a call to some other part within the organization to understand that there is a report for the app is down. So I can get that information from some other part of the organization that app is down. It can inform the customer that, sorry, that's correct. Our app is currently down. You don't have access to the app. So I don't need to send it to the RAG. So that's how basically we are bringing in this agentic AI to cover different problems or different aspects of a kind of interaction with the customers. What does it contain, right? It contains memory. It can be short-term memory and long-term memory. Long-term memory meaning that I have the history of your interaction before, maybe 1 week ago, 2 weeks ago. I can utilize that memory. I have tools at hand. So we know that LLMs are not built for doing calculation. So they are just predict one word at a time based on all the previous words. They are not good at calculation. We can provide them some tools. Okay, this is a calculator. This is a calendar. It can be some other things as well. You can add it to the tool. Then you need to do some sort of a planning, or you can call it a design pattern, which you can be very creative on that. When you collect all this information, how would you react with it? So you do the chain of thought, or how do you plan? If a query comes, how do you plan to approach it? These are all the design patterns. So this is in a nutshell what is happening in agentic AI, and it's evolving so fast. So
Moji,
whatever
can I pause? I
yeah,
asked
sure.
2 questions in the chat. If you
Yeah,
can shortly
sure.
answer them, that would be great.
Yeah, tell me.
So, what are the best practices for fine-tuning a RAG model for a specific domain, like, say, such as health or banking or legal domain?
Yeah. this is a good question and sometimes a tough question. So essentially evaluation, maybe that's something that I didn't bring it up. So as I said, we moved from a naive RAG to advanced RAG. There are a lot of knobs to tune. So what knobs to tune, it depends on indeed your use case. And it's very important to build some sort of ground truth. That's the best way. It might be at the beginning time consuming, however you will benefit from that. Because not necessarily one size fits all approach when it comes to RAG approaches. It really depends on your data, defining that data set, basically I would call it ground truth, and also depends on business requirement, because business also might ask certain requirement. I want to have a tone of voice of very formal. I want to have a tone of voice of like a human. So this is also a requirement from business coming to you. Then you need to incorporate it in your basically system. So the best practices is a very good evaluation, basically metric. This evaluation metric can be from LLM perspective. It can be from a business perspective. So LLM, and especially RAG, you have two important components. It's a retrieval part and a generation part. There are a lot of different metrics to basically evaluate retrieval part and also generation part. And don't forget human, because it happened to me and maybe many others that based on those metrics that you define on a retrieval and a generation part, you get very high score. But when you give it to human to evaluate it, you see that, okay, not good enough, not good enough.
Yeah.
So there are a lot of things that you need essentially balance it out. So I would say that you should do I would do two steps. One step is that there are common metrics to calculate on a retrieval side and generation side. And the second step is that human to really go through some of the cases.
Yeah, got it.
I hope it answers your questions.
Yeah, and okay, and I have my second question. As you know, knowledge graph is a hot topic around
Yeah.
RAG days. It's like going to the moon and back. How do you think the use of a knowledge graph compared to a vector database impacts the accuracy of the RAGs right now?
Very good question and tough question. I don't have per se answer for that. It depends. You know that as far as we know that where graph RAG will be very powerful. I think there is a two aspect in it. One aspect is that you need to build that ontology.
The
So
semantic.
no matter you're gonna use it in a graph RAG or not, if you build that ontology, you're gonna gain a lot from that. So the second thing is that we know that RAG will suffer for a question that it's a little bit of a holistic questions, I would call it, like what was the sales in 2025? So meaning that you have to go through many different chunks or documents to collect those information to give this basically a general overview or general answer. RAG a little bit suffers from that, but when it comes to graph RAG, it will be able to put together this information and generate this answer. I don't have a clear, basically, what I have seen so far that I've seen people build graph RAG, but it requires time. You need patience. It
In
took some
industry.
time. Was that?
You
Yes.
saw it in industry. Okay, great.
Yes. I've seen it. Our partners basically did building a chatbot based on graph RAG. But what we learned from them is that it took some time for them to get that graph RAG correctly. As I said, It depends that how patient is your business and how you can convince them. But building that ontology, you can benefit a lot from that, I would say.
Thanks, Moji.
Yeah. Okay, let me give a bit of a pace because we have some interesting stuff that you might like it. Okay, you might ask that how we are going to build it, this agentic application, right? So what is happening in business? So often in business, I mean, there are two scenarios. Either you go toward building everything in-house using open sources, or moving toward the cloud providers. And often in business is a tendency toward the cloud providers. There are a couple of reasons behind that. One is that if you want to do it everything in-house, then you need much more people involved to maintain it. It's a bit much easier to maintain it if you use or utilize a cloud. And the second thing is that most likely, most of the companies have already some of their data already cloud. So it's much easier to bring all those different components and to build it. So I just brought a simple picture of how one could build a chatbot in Azure. So I have a user on the left side, right? I have a Microsoft Copilot. Why do I build or add a Microsoft Copilot? It's optional. You can exclude it, but it's important because you can put some business logic there. So, and Microsoft Copilot can have access to, for instance, Microsoft Dynamic. If you use basically CRM there, basically all the customer information is there. It has it will be integrated with them. So what you can do with that, you can get that long-term memory I told in the previous slide. So all the customer interaction is essentially stored in a Microsoft Dynamic. So Microsoft Pilot can get access to those information and send it to basically our chatbot on the left side. On the left side, what we have is a prompt flow where our basically agent structure is there. It's a tool from Microsoft. On the back, it connected to an LLM. As well, you can use OpenAI on a Microsoft Azure. Then you need to have a Azure AI search and Azure storage. In the storage, you can basically upload your documents there, and it will be indexed and vectorized in Azure AI search, where prompt flow can basically send a request and receive those answers, basically retrieve documents from Azure AI search. So how it works in Flow, user send a question to Microsoft Copilot. As I said, Microsoft Copilot can play the role of a business logic. Business logic can be that if suppose a customer doesn't want to chat with the chatbot, right? Customer says that I want to talk to a human agent. I don't want to talk to a chatbot. So Microsoft Copilot, what it does is that it basically, instead of sending that user query to a chatbot, send it directly to a human agent. So you can call it that Microsoft Copilot plays the role of the business logic there. So, but suppose in our case that the user wants to use chatbot, send it to Copilot. From the dynamic, you can get all those long-term memory and its interaction and send those information to prompt flow. Query will be sent to Azure AI search to get relevant content for that. And that relevant content with the user query and memory, send it to OpenAI, Azure OpenAI, to generate a reply and send that reply back to the user. You have an application inside to basically record all those user query response for evaluation purposes. This is a simple version of basically how you can build an agentic application in Azure. Any question? So I believe we still have some time. If you like, I want to show you something maybe interesting. So has anyone used N8N? So let's send it to you. Maybe you can also. Where can I find it? I cannot. I shared with you this link. You can go to this website N8N, and if you like, you can sign in. Basically, start a free trial. It will be easy. You can do it now if you want. It's up to you. I just want to show you that how it works. I'm not the sponsor of this place, N8N, but I found it very easy and convenient to show you something. It's simple and easy to basically create an AI agent. So you have an OpenAI model. It gives you some also free access to use it for a couple of, I think, 100 API calls. There is a memory. As we discussed, for AI agent, we need also memory, OpenAI. What I have done is I added to my Google Calendar and also added Wikipedia. You can add many other things you want, I would say. It's quite easy to build basically AI agent for yourself here, but I use it just for the purpose of the showing that how it works. Anyone question? Are you with me? Okay, it's easy, fast to create it. I think if you log in and manage, you get quickly this one. So what I have done is that I just added the Google Calendar, I just added Wikipedia, and I will start to chat with it and to see that how it works, right? So what I would do is, yeah.
One question, Moji, this is completely free to use and test?
Yes.
Okay, nice.
Yeah, you can go in it. I think you can have 100 API call for free. So I use it for this purpose. It's quite interesting. So what I would do is that I just say, hi, how are you? So obviously what I expect that, you can also define, see, if you click on it, I didn't explain, this is your system message. So I said that you're a helpful assistant, you access to my agenda to get updated information, access to Wikipedia if you're not certain about certain answer. You can very nicely tune all the details. So I said, I hope it works. I hope it doesn't fail. So I said, see, okay. I said, how are you? It went to AI agent. I don't need to go Wikipedia and Google Calendar. It goes to OpenAI and it quickly answer, right? I'm just a program, but I'm here ready to help you. How can I assist you today? So it has access to my Google Calendar. I would say that what is my agenda next week? Show it to me per day. So obviously it went to Google Calendar because I asked, so got the information, and now it's basically generating answer. Obviously next week I'm not that much, okay, I have nothing in my calendar, I would say. Okay, it looks like that you have an event on Thursday, but no other things. That's good. Okay, it also put a link to the event. So let's see. So, okay, let me try my name. So obviously, I guess it cannot find anything in my name. So it should go to Wikipedia as well to check whether it can find my name. So yeah, see that it went to Wikipedia. Okay, I couldn't find any information on my name in Wikipedia. You can see that how this basically agentic AI try to utilize different tools to basically generate answer for you. Any question? No?
Guys,
Okay.
feel free to ask questions, please.
Yeah.
Yeah?
Do I
Okay.
have a question? Do I have a time, Marzi?
I think, Thomas, you have a question. Feel free.
Yes, thank you. I want to know about the memory of an AI agent. We know that for to the agent to respond promptly, he needs to have memory of previous conversation and everything else. So, and also we know that LLM has a limit of how many parameters can come into it. So he can answer. So it longer the conversation goes on, it longer the number of parameters can use to process it. So my question is, how do we manage how much memory we have in an application like this if a user is keep using the application over a long period of time? So there's some most important information to keep track of it, or we keep sending to the LLM all the information that we have interaction with that user throughout all the time. I don't know if it makes sense.
No, it makes sense. It's a fair point. But we have different points here. First of all, currently, most of those big large language models can handle quite long, basically tokens. I think essentially it's not a big problem in the sense of you will have a problem with the context window. However, you will get a problem with latency. So, meaning that then the LLM should go through quite a lengthy conversation, and it will be a problem to answer. It's not a big problem at the moment, per se, I would say, because, but I can imagine that if you want to, it depends how long of a history you want to keep. You can say that I don't need to keep the history of, for instance, a customer when it comes to chatbot for 2 years. You can have some sort of a cutoff point for that. But in general, you have a fair point. I haven't seen a case that suffers a lot from this problem, if I want to be honest. But I can also foresee that we might see it in it happens that too much of an information, you get a problem with the latency. There are things like that. Basically, there are some approaches trying to look into it. One approach is that, okay, maybe we need to truncate those information, how much of past information needed. Or the second approach is that maybe we need to summarize it. So using another LLM to summarize that history in a shorter text, then provide it to LLM to generate a response. In principle, it's a valid concern. But it's not a bottleneck, I would say now, but it might, in some use cases, you might face it because of the long history, mainly in the latency part. And obviously, it's also more expensive. You have more tokens in your context. Does it answer your question to some extent?
We have another question in the chat.
Yeah, sure. Can you read it for me, please, Marzi?
It says, what do you think about the traditional NLP tools such as NLTK, Spacey, Vortex, and their importance in the future when today even SLMs are powerful enough to perform most of the NLP tasks like NER, sentiment analysis, summarization?
Yeah, very fair point. Very good point and fair point. So I wouldn't say that it won't be no longer used, because let's put it this way. So if I want to build a search engine, this is completely my perspective. So someone else might have a different perspective. If I want to build a search engine and you put a query on that, right? I don't know. Suppose you want to go to Amazon, I don't know, some other e-commerce, right? You put a word there. If I want to utilize LLM to go through, I don't know, 100K of different product to find what you want, with LLM is overkill from my perspective. It's completely my personal opinion, and it might take much more longer than you expect. I believe still tools like Spacey, those, Spacey, Stanza, if I'm correct, and other old tools still applicable when it comes to the latency, how fast, when it comes to search engine, I would say. That's, as I said, my personal opinion. But obviously, using for topic modeling or sentiment analysis, LLMs are much powerful to capture those, context information, and it won't be. Yeah, you will move to LLMs rather than using a Spacey and NLTK and some old-fashioned, not old-fashioned, older type packages. Does it answer your question? Yeah, okay. If you have time, I can show you some other things, but Marzi, I think if...
You have 5 more minutes, Moji, so...
5 more minutes, okay. Then I can show you at least one more thing. It's something that I built for myself. I showed you basically building in a chatbot using or utilizing those cloud providers. I built something for myself. But essentially, when I build something for myself, it's a bit of a low budget one. So you're trying to utilize all those open sources available. I would call it the Kavosh agent. Marzi knows Kavosh is a Persian word for search. So why I build this? Because I really like to read papers. So I build this, basically goes through archive, if you know it, and send me all those most recent papers relating to a certain topic. It will, for me, summarize it and give a link. Then if I like it, I will add it to some sort of a vector database. So that's something that I built for myself, utilizing, as I said, this is a low budget agent. What I have done and utilized is that using a line graph to build that agentic framework. I use FAIS as a vector database. Well, I use OpenAI. You can use some open source models from Hugging Face. How it works is that I put it in a GitHub. Each time that I build a CI/CD pipeline, each time that I create a new feature, I will merge it to the master. It will create a Docker image, load it in a Docker hub. I host it in a Render, is a host provider, and it's connected to my Telegram channel. So essentially, that's how I communicate it with my agent. I'm lazy. You can build a nice front end for yourself, but I'm using basically Telegram. Under the hood, what it does, quickly, it tries to understand what is my question. If it's just a hello, how are you? It goes to generate a greeting. If I ask for, give me the most recent paper about certain things, it goes to search an archive and generate the answer for me. If I need to extract some information from my vector database, it goes to the vector database and grab information. It's a RAG, it's a version of basically a RAG to extract the information. So let me show it to you. So do you see my screen?
Yes, yes.
Okay, this is my Telegram channel for myself, or Telegram bot. It's a bit slow because, as I said, it's a low budget. So give some time to fire off the answer. Okay, until it try to find the answer, let me show it to you something. So I said that I put a Langfuse as a kind of a monitoring. What it does is that I go to Langfuse, I monitor everything here. Essentially, I see that how many calls I made to my agent, how much was the cost. I'm using GPT 3.5. As I said, it's I'm going for a low budget API call. Here you can see essentially traces. So how many calls happened? Still trying to, okay. Well, okay, it's trying to fire up still. Here it shows to me that what sort of a question I ask and where does it go. So for instance, last night I asked what are the most recent papers about LLMs. You could see here that it goes to question intent. It's search in archive. It's a website, generate answer and send it to me. The other question I asked yesterday was just hello there. What it does is that it goes to question intent, generate greeting, and the end. So that's what you can get. Okay, still thinking, it doesn't matter. I can show you that what I said. That's what I mentioned yesterday. Hello there. So that hello, how can I assist you today? Which essentially was that trace that I showed to you, right? This one. It went to try to capture the intent of my question, generate greeting and end. That was my query, and that was the output. And you can see here also the cost and also the latency here. That's how I monitor it. So my agent. So the second question that I asked was that what are the most recent papers about LLMs, that it listed all the papers, most recent papers in LLM with a link that I can, if I'm interested, and then also short summary, if I'm interested, I can look into it and understand that what's happening there. And indeed, it was basically this one. And indeed, question intent, search archive, and basically generate a summary of it and send it to me. That was my question, and that was basically output with a lot of those answers. You can define some evaluation metric like LLM as a judge to define that hallucination, some other metrics that you like. As I said, I'm not here to advertise LangFuse, but I'm just showing that how basically I build my own, still thinking, but it's okay, how I built my own agent for myself using some open source tools that I don't need to spend a lot of money on that. Any question? Because this will summarize my talk.
Yeah, Moji, there are some questions in the chat.
Yeah, sure.
So one is a question about privacy about N8N.io, the one you introduced. Where do the upload data end up? Is it possible to use it for a company? Like for the privacy, is it possible to use it for company data?
That's a good question. I don't know. I don't know, to be honest. As I said, I don't know this N8N too much, but I just found it very easy to demonstrate to you that how agents works. I think it's something that you need to basically dig into to understand it. I don't have any advice regarding N8N.
Sure. Do you guys have any other question from Mojtaba? Okay, then thank you Moji so much. I learned a lot personally, and I liked that you already made a personal one for yourself to read the news more efficient. I want to use it, share it with me. And thank you so much for today's talk.
You're welcome.
Guys, I'm gonna put Moji's LinkedIn on the chat. Feel free to add him. If you had any question later, you can ask right away.
Yeah, definitely. If you have any questions, you can reach me out and try to help you.
Yeah, okay. Thank you, Mojtaba. You can
You're welcome.
and then we will continue the class.
Good luck, guys.
Thank you, Mojtaba.
Bye bye.
It was very insightful.
Thank you.
Thank you.
All right, thank you.
Thank you.
Thank you.
Thank you, Professor.